Support Microbe TV. It's time for our annual fundraising drive. We depend on your support to produce high-quality science videos and podcasts, and now is the time to help us. If our programs have appealed to your science interests, or if they have helped you in some way, please record a brief audio or video with your phone and tell us about it. Let us know how we empower your inner scientist. We'll use it for our fundraising efforts. Send it to incubator@microbe.tv. And for more information on how you can give us your support, go to microbe.tv/contribute. This Week in Virology, the podcast about viruses, the kind that make you sick. From Microbe TV, this is TWiV, This Week in Virology. Episode 1183, recorded on January 3rd, 2025. Happy New Year, everybody. I'm Vincent Racaniello, and you're listening to the podcast all about viruses. Joining me today from Ann Arbor, Michigan, Kathy Spindler.
Hi, everybody. Here it's 27 Fahrenheit, but it feels like 8 Fahrenheit. So that comes out to be -3 Celsius, feeling like -13 Celsius. It's kind of cold feeling.
Here it's 4 degrees C, and it feels like -2. It's pretty cold. Yeah, but I think it's supposed to snow today or next week or whatever. I don't know. Also joining us from Austin, Texas, Rich Condit.
Hi, everybody. Let's see here. We've got 62 degrees Fahrenheit. And I'm surprised that Tinkerbell is even here because I guess it's overcast, but it's nevertheless bright. Okay, it's sort of, I guess, a high, thin overcast or something like that. And in other meteorological news, the forecast, which seems pretty steady, is for a freeze early next week. Which will be the latest freeze in Austin for quite some period of time. But we're looking at maybe 30 degrees on Sunday, 28 on Monday, 32 on Tuesday and Wednesday. So that ought to take care of this year's plants. And we get to start, that's okay with me. I get to start over. It's all part of the thing.
Also joining us from Madison, New Jersey, Brianne Barker.
Hi, great to see everyone. It is 37 Fahrenheit, 3 Celsius here. A little bit cloudy, but not too much. And I think it's going to be quite cold this weekend and some snow early next week.
I thought you were saying 37 Celsius. I'm thinking that's pretty warm.
Yeah.
So what did you say your temperature was, Vincent?
It feels like -2 Celsius.
Okay. So you guys, it's cold. Kathy,
it's cold here.
Definitely cold, right?
Yeah.
One day last week it was -12 Celsius. It was really
Kathy,
cold.
have you had snow?
We have had some snow, but nothing significant.
And there's a forecast for some snow in the east coming, right?
There's a forecast for some snow coming in the east. And actually right now at my parents' house in upstate New York, they were supposed to get something like 4 feet in 4 days.
Ooh. Wow. That's exciting. Where's that in upstate New York?
Town is called Camden.
Camden.
Yes.
Right. Camden, New York, Camden, New Jersey. Probably
Exactly.
more.
Very different places.
The 25th this year had snow on the ground. It was just like 2 inches, but it was white. So I went and looked up the words to that song, White Christmas. I hadn't seen snow on the ground on the 25th in ages.
It's a California song. Did you figure that out from the words?
No, I didn't.
Oh, okay.
Do you know who originally sung it by any chance?
White Christmas.
I'm thinking Bing Crosby. I mean, I know
there's a movie that it was in.
Mm-hmm.
Oh, I'll bet you that's Bing Crosby.
I mean, a lot of people did sing
a lot
it
of covers
eventually.
of White Christmas.
I mean, I like Frank Sinatra's cover.
So,
anyway, there's a great line in it. It goes, "May your day be merry and bright."
Yeah.
So I was telling people, I hope your day is merry and bright. Bright is a great word, right? Hope your day is bright. I like that.
Okay, here's the details. It was in the movie Holiday Inn, 1942, won the Academy Award for Best Original Song. It was originally sung by Bing Crosby. It was written by Irving Berlin, as we knew.
Irving Berlin.
Mm-hmm.
It's very good.
But the whole thing about longing to be up north.
Is that why they say like we used to? Hope it's white like we used to know. It's because they moved.
It's because they're in California. I'm pretty sure.
I'm thinking, couldn't be climate change. It's just too old.
Yes. Here's the line. The sun is shining, the grass is green, the orange and palm trees sway. There's never been such a day in Beverly Hills, L.A. But it's December the 24th, and I am longing to be up north. That's the lead-in to I'm dreaming of a white Christmas.
I'll be darned. I always thought, because we sing this in the barbershop chorus, and I always thought that intro was, as is not untypical of barbershop tunes, some barbershop arranger's idea of a clever intro to a well-known song. No, that's the original thing, huh?
Yep, Irving Berlin's opening verse.
I'll be darned.
And I have sheet music with that on it. So when you were going through that, I was like, no, it's L.A. But
so the version I found doesn't have any of those lyrics. It's just
the white Christmas, just the chorus.
I'm dreaming of a white Christmas, just like the ones I used to know.
Yeah.
Yep.
And I'm wondering, what is it? What is that? What California? Because there are no California clues at all in the version that I found.
It's because it's missing the verse. Go to Wikipedia and you'll have the original
The reason
verse.
is that it's a cover by Michael Bublé, 2003, and he just changed all the words. Right? Ah, interesting.
So I got to cycle back to the weather here for a second. I'm looking at Camden on the map here because I have some experience with upstate New York.
Yes.
So is that, you must get lake effect snow from Ontario, right?
Yes, that is correct.
So that's probably where that 4 feet's coming from.
Yes. Usually if you look at Lake Ontario and you imagine the lake effect band, it looks sort of like a club. And Camden is sort of the place that gets hit over the head by the club.
Yeah, it looks like it. It looks like it's about the same trajectory as Orchard Park, where the Buffalo Bills Stadium is from Lake Erie. You know, if the wind is coming from a little bit of north and going a little bit from the northwest and headed for the southeast, you get clobbered. 4 feet in 4 days. Wow, that'll be spectacular.
This is what I've been told. I haven't seen it yet.
Yeah,
my parents.
You know, we have a local weatherman who's very good and does his own forecasts, and he's constantly telling us, don't pay any attention to the Weather Channel because that's all just computers messing with your head.
I've been watching some videos take place in Sweden. You talk about snow. This guy, he said, if I don't take the snow off the roof, it's going to collapse the house because it was just sticking there. It was so cold. It was amazing. He's a mechanical person. I don't know. He has this crane with a claw on the end. So he picked up a big log, and he used it to stroke the snow off the roof. Isn't that amazing? Love it.
So this is the podcast all about viruses, right?
Oh, I forgot. Yes, the kind that make you sick. Yes. Okay. All right. Let's get back to this.
For all of you TWiV fans out there, you just got a good dose.
On point. Release the viral immunologist in you. The Rosenfeld Laboratory in the Division of Viral Products at CBER FDA is looking for a postdoc staff scientist to continue the lab's research, understanding the immune responses elicited during antivirus infection. If you're an immunologist, microbiologist, or virologist wanting to learn more viral immunology and vaccinology, email Amy at amy.rosenfeld@fda.hhs.gov for more information. What's up with ASV, Kathy?
Well, I just put it in bullet points. ASV 2025 will be in Montreal at the Palais de Congrès de Montreal, July 14th to 17th, 2025. Website is asv.org/ASV 2025. Abstracts are due February 3rd, which by the time you hear this is less than a month away. Travel award applications are due February 5th, just 2 days later. And you should renew your membership or join ASV, especially if you want to submit a travel award application or use the childcare opportunities. So there you have it.
Okay. Now, this is the first episode of 2025. We traditionally do a year in review. The past year in virology. So we each pick a couple of stories or story arcs that we liked, and we talk about it. So I'll start off with SARS CoV-2 Origins. Now we did a lot of episodes before 2024, and in fact, we did a TWiV special in the summer last year called How the Pandemic Began in Nature in 5 Key Points. And in the show notes, it lists all of the previous episodes that we did on SARS CoV-2 Origins, including interviews with people like Eddie Holmes, Robert Gary, Peter Daszak, Thea Fisher, Marion Koopmans, Christian Anderson. So we've done a lot. Yet, sadly, the nonsense continues. And I was talking to Kathy before we started recording, and it's very frustrating. I just don't understand it. I get letters regularly saying, "I'm sorry, Professor, but you're just wrong." Oh, really? Where did you get your PhD in virology? Tell me. I'm not just wrong. We've been reporting the data for the past 2 years. The virus came from nature. It did not come from a lab. Anyway, a very good episode to listen to is the TWiV special. It's actually an excerpt of TWiV 1121, where we had other topics, but I broke it out, so it's about an hour. It's in response to a New York Times opinion piece by Alina Chan, which is basically all wrong, all fake, all nonsense. None of it is true or correct in any way, yet people, I guess that's right, because it's in the Times, right? And we go through all the points that she said, 5 reasons why it came from a lab. So we said 5 reasons why it came from nature, and rebutted all of her points. The problem is that there really is zero evidence for a lab origin. There's speculation, there's innuendo, and I'm going to go through some of it very, very briefly. But there's plenty of data that clearly shows that the marketplace, the Huanan seafood market, was likely the early epicenter, and there were multiple spillovers from animals. But many people, including the select subcommittee on the coronavirus pandemic coming from Congress, don't seem to have read those papers. Anyway, so TWiV special, we rebut that opinion piece. And then we have TWiV 1155 called Spillover in Stall A. And here we review a really nice Cell paper where the previous year, environmental samples were sequenced to find traces of SARS-CoV-2 and also what kind of animals were there, because they could sequence the mitochondrial DNA and look at the species. And so in this paper, it's called Genetic Tracing of Market Wildlife and Viruses at the Epicenter of the Covid-19 Pandemic. I just want to point out, this is a peer-reviewed paper. A lot of people reviewed it, and in the end, they said, okay, you can publish it. And the conclusion is the epicenter of the COVID-19 pandemic. Anyway, they took and they found DNA of wildlife species that are known to be susceptible to SARS-CoV-2. And in the same samples, they found SARS-CoV-2 in a very specific part of the market where they sold mammals, and that's stall A, right? And the species are all consistent with animals that could have been infected somewhere else and brought into the market and led to a spillover into people. There's nothing wrong with this paper. The people who push a lab origin, they don't even cite this because it and a few papers from last year are really fatal to the lab origin hypothesis. You can't mention this and say it came from a lab because the data are so good, right? So that's a really excellent paper. More recently, TWiV 1179, we mentioned, so Zhongli Shi, who was formerly at the Wuhan Institute of Virology, she's now a senior scientist at Guangzhou Laboratory, a newly established research institute for infectious diseases. She gave a talk at a meeting saying, okay, we have all these samples in our lab, which are bat samples, basically. We sequence them all. None of them are any closer to SARS-CoV-2 than RATG13, which at the beginning of the pandemic was the closest, about 1,200 nucleotides different, and which can't be the precursor to SARS-CoV-2. It's too far away. And she didn't have infectious virus. She only had samples in nucleic acid sequence. So this clearly shows there is nothing near SARS-CoV-2 in the laboratory. And so you can imagine retorts from the pro-lab leakers, but I think that this really shows that there's nothing close to it. And then finally, something we didn't cover on TWiV. This December 4th last year, the Select Subcommittee on the Coronavirus Pandemic, chaired by Brad Wenstrup, issued this 500-page report on the pandemic. It covers all aspects of the pandemic, not just lab origin, but the usual political crap. Why we shouldn't have made people wear masks, right? President Biden made people wear masks, overstepping his boundaries. Lockdowns, we shouldn't have done this. All this crap, which we've visited multiple times. But I wanted to point out a few things. So in the very introduction, there are a few quotes, which just really something. So one of them doesn't have to do with origin. They're talking about scientific messaging during a pandemic, okay? The importance for clear communication. And here's the quote: "Scientific messaging must be clear and concise, backed by evidentiary support, and come from trusted messengers such as frontline doctors treating patients." Okay, if you want to know about clinical issues, fine. Find a frontline doctor. But the ones treating patients are not likely to know any basic science. And today, the ones treating patients, most of them don't even want to prescribe Paxlovid, the antiviral. If you want to explain the science, you need a virologist, not a frontline doctor. I mean,
unless that frontline doctor is Daniel Griffin.
Unless it's Daniel Griffin, right. But I don't think they have Daniel Griffin in mind. I mean, this is just crazy. Anyway. Then another quote: "The U.S. National Institutes of Health funded gain-of-function research at the Wuhan Institute of Virology." These are like little bullet points supporting their... So what if they funded gain-of-function research? Gain-of-function research is a huge term. They don't understand that. They don't understand that it's just giving a new property to any organism. They think it's just dangerous stuff. And this really pisses me off that they don't know the fundamental definition. Now listen to this next one. Oh my gosh, RFK Jr. is rolling in his grave. Quote, "Operation Warp Speed was a tremendous success and a model to build upon in the future. The vaccines, which are now probably better characterized as therapeutics." What?
Vaccines are not therapeutics in this case.
No. Undoubtedly saved millions of lives by diminishing likelihood of severe disease and death. Oh my gosh, they're actually saying, and this is the majority members of this committee are Republicans. The minority are Democrats, right? Because that's how it works. And they're saying that the vaccine fast development is amazing because so many people have said they were developed too fast and there are problems with them. So I thought that was interesting. And then finally, another one, quote, "The prescription cannot be worse than the disease, such as strict and overly broad lockdowns that led to predictable anguish and avoidable consequences," unquote. Well, you ask the people who have long COVID now how they feel, okay?
Or the dead people.
Or the dead people. This is just political nonsense. It has nothing to do with public health. Okay, now I'm just going to talk a little bit more about the origins part. So as I said, there are many, many other parts, like they're pissed off at Governor Cuomo for doing something with nursing homes and masking and this and that. But they had witnesses for each of these sections. So for the sections, people who testified about origins, these were the people. Dr. Jamie Metzel, who's currently in the Atlantic Council. He's a geopolitical commentator. What the heck does he know about virology? But he's going to say what they want. Dr. Robert Redfield, former CDC director, who has said, oh, yes, the virus clearly came from a lab. What the heck, Redfield? I mean, he's the one who said, years ago that AIDS was a gay disease also. So this guy is disqualified. Mr. Nicholas Wade, former editor for Nature and Science, former science editor for the New York Times. Not a scientist, not a virologist, that's for sure. Dr. Paul Atwater. So this is the minority witness. So the Democrats picked him. Okay, he's an infectious disease doctor at Johns Hopkins. And if he's as well-versed in the basic science as Daniel, that's great, but I'm not sure he is. Okay, they should have got a virologist to testify. All right, and Nicholas Wade. Here's a quote in the paper in the report. Quote, in January 2024, Mr. Wade voiced his increasing support for a lab incident origin. Mr. Wade astutely noted, the words of the committee, that SARS-2 possesses a furin cleavage site found in none of the other 871 known members of its family, so it cannot have gained such a site through the ordinary evolutionary swaps of genetic material within a family. Mr. Wade, so astute. Did you ever think that maybe we didn't sample enough to find furin cleavage sites in other viruses? And since then, we have found them in other coronaviruses. And did you ever think that it wasn't recombination that gave this site? Like it could be mutation, Mr. Astute Wade.
So as I read that, one of the things, that last quote, one of the things that occurs to me is that whoever wrote this into the report probably had not the slightest idea what they were saying.
That's right. That's right. All right, one last thing, and then we'll let someone else talk. So where's the website here? Yes. The report is very long. Very few people are going to read this, but there is a website that summarizes their points about origins. And I just want you to listen to these and understand how ridiculous they are. Okay. So it says COVID-19 origin. COVID-19 most likely emerged from a lab. First of all, COVID-19 is not a virus. Okay. So this immediately tells you they don't know what they're talking about. Most likely emerged from a lab in Wuhan, China. The 5 strongest arguments in favor of the lab leak theory include, okay, you ready? The virus possesses a biological characteristic that is not found in nature, and that would be the furin cleavage site.
And that's wrong.
Why does it say it came from a lab, though? I don't even understand that. What kind of science is that?
True, yeah.
I mean, it's wrong. It is in nature.
Right.
But just because it has a property that you haven't seen elsewhere, well, that's probably what makes it a pandemic virus. It doesn't tell you that it came from a lab. Oh, my gosh. I mean, all these things, if a PhD student at their defense answered them this way, I say, go back to the lab and study another year. What are you doing? All right, number 2. Data shows that all COVID-19 cases stem from a single introduction into humans. This runs contrary to previous pandemics where there were multiple spillover events. Well, if you read the bloody papers about the market, you'd know there were more than one spillover event. How can an official congressional report get it wrong? Number 3, Wuhan is home to China's foremost SARS research lab, which has a history of conducting gain of function at inadequate biosafety levels. This is all hearsay and innuendo. It's not any evidence that it came from the lab, right? Number 4, Wuhan Institute of Virology researchers were sick with a COVID-like virus in the fall of 2019, months before
That just won't go
COVID.
away.
And
there was no proof that it's a COVID-like virus.
No,
they
in
were
months,
sick. That's it.
There was no circulation months before. It's very clear. It's very, very clear. And Thea Fisher and Marion Koopmans on that episode with Peter Dasher, they said there's no evidence that it was COVID. We don't know what it was. It probably wasn't COVID.
It was flu season.
Flu season. And this is the last one. This is just ridiculous. By nearly all measures of science, as if you know what a measure of science is, right? If there was evidence of a natural origin, it would have already surfaced.
Yeah.
It has surfaced. Oh my gosh. Anyway,
Right.
If you read this, you're going to get really pissed off. If you are a scientist and you use data to make conclusions, that is. This is not going to die. It's probably going to get worse as we enter the next administration. And I'm sure it's going to be an issue this year. Okay. I'll relinquish the floor. Rich, you're next.
Okay. On a brighter note, for me personally, the highlight of this year in TWiV was my attendance at the hepatinovirus meeting, the HBV meeting in Chicago in September. And this was a stroke of luck for me. Bad luck for others. Vincent was unable to attend, and so I was fingered to help out with this, and it was delightful. And I will say that you can see the podcast at TWiV 1163, which was published sometime after the actual event, called Hepatnoviridae in the Heartland. And what you'll see is that Vincent was able to zoom in. And I thought that technologically and in all other ways, that really worked well. I was really impressed. I was a little nervous about that going into it. You had done it before, but I had never done one like that before. And it was really nicely set up. And I thought it was seamless. The organizers were Alex Ploss and Matteo Iannicone.
Iannicone, yeah.
Iannicone,
yeah.
And I had an opportunity to spend some time with them, and they did a fabulous job organizing a meeting. And they're very interesting people and good to talk to. And the guests were Mala Maney and John Tavis. And I will say a little more about them. This was a somewhat unusual setup for a TWiV, for a live TWiV. Though not that I've done all of them, but usually what we do is we pick out of the speakers or somebody, a couple of people, and interview them on their work and stuff. But the organizers, Alex Ploss and Matteo Iannicone, they were on a mission. And their mission was to use TWiV, among other things, to broadcast the mission of this HBV group and the issues with hepatitis B virus to a broader audience. And so what they wanted to do was pick out a couple of individuals who had a very broad and experienced perspective on the virus and interview them so that they could go over the whole thing. And Mala Maney is an immunologist who could provide the immunology perspective, and John Tavis is a molecular virologist who could provide more of the molecular virology details. And unlike a lot of other TWiVs where we like to not talk too much to the guests before so that it's spontaneous. In fact, I spent some time with these two individuals to kind of go over what the expectations were and that kind of stuff, so that they had they could think about it going into it. And I thought, and then Vincent and I, as usual, put together a list of questions and split them up for the actual interviews. And I thought it went very nicely and managed to cover the whole thing. So I feel like it was a real success. I also was introduced to the HBV Foundation. The Hepatitis B Foundation, it has an international reach, but it's U.S. based. It's a private nonprofit organization that exists for the purposes of support of HBV research and communication of the issues with HBV, and they help out with this meeting. I was able to do bonus interviews, what I'm calling bonus interviews. I interviewed a scientist named Stefan Urban, who is responsible for the development of an anti-hepatitis delta virus drug called, I'm going to screw up the pronunciation, Bulevirtide. Bulevirtide. It's a polypeptide that blocks the hepatitis delta virus receptor. And is quite effective. And I had a wonderful conversation with him. He's a very interesting man. Also interviewed Thomas Tu, who is an HBV researcher, and one of the important things about Thomas, and interestingly, I had met him just independently at the meeting, and then he surfaced for this interview, is that he is a lifelong HPV carrier, and this chronic HPV infection is a big deal. And it's a big deal for the science and for the disease. And it's also a big deal socially. And I did not have as much, I gained a lot of awareness of this at the meeting, in that there is or has been stigma associated with being an HPV carrier, much the same as there has been stigma in the past associated with, having HIV or a number of other health issues. And part of the mission of this meeting and the HPV Foundation and et cetera is to destigmatize that chronic infection, because that helps the people who are chronically infected through no fault of their own. Thomas acquired his at birth, which is not uncommon, from his mother who happened to be infected. It helps destigmatize it for those people, and in doing so, makes them and others available better for treatment and et cetera. And lastly, I interviewed Sherry Cohen, who is the current president of the HPV Foundation. What has happened to those interviews? Have they been posted anywhere, Vincent?
Not yet. They're just now. The editing is almost done, and
Okay.
we're going to start
Good.
posting them in the next week.
And I have to say a couple of other things. Technical support was from Karen Irwin, who is the Microbe TV crew. And I really enjoy working with Karen, and I got an opportunity to work with her more. She's, I think the phrase is probably piece of work. She's a very interesting individual who does her job. She lined up all these interviews. She got them all straightened out. She did all the tech. She did all the tech on the Zoom stuff, and she is right there and does a great job. I've learned, I've learned a lot of sound tech from her, and I really enjoy working with her. So that was fun. As I said before, the Zoom interface I thought worked really well, and I was pleased with that. It was seamless. My one regret is that we did not, in the interviews, cover hepatitis Delta. I think we were concerned that we were might run short of time, and Delta is a big topic. So it would have been nice to at least mention it. So I'm mentioning it here, so we know about it. Another time, perhaps. So, great meeting. Enjoy
Rich,
the
I'm
episode.
so excited about those bonus interviews. We did some similar we did some similar ones for immune this year. I guess that's a new thing in 2024. And they were awesome. And so I can only imagine that these are going to be great too. I can't wait to listen to them.
Thanks, Rich.
Yeah.
Kathy,
Well, thank
do you
you,
have for-
because I really enjoyed going.
Well, okay. Now I'm taking a cue from Rich, and for me, the highlight in TWiV presentation was being at the one in Australia, and it was the trip of a lifetime to get to go to Australia, and so I'm really grateful for that. Karen was fabulous there too. I was a little bit worried about all the tech and how everything would work, but not only does she do all the things that Rich said, but she parties hard, and she's really fun. So there's that. The meeting had a scientific organizing committee that was Rebecca Cox and Mark Tompkins, and a local organizing committee, Kirsty Short. And so I owe it to them, we owe it to them that we had a TWiV there. And then, so the TWiV that we did was Steph Langle from Immune and I were the co-hosts. And then Vincent was there on the large screen from New York in a different side of the date line and everything. And we had guests, Stephanie Grah and Jenna Guthmiller. And then Vincent did a separate one at the School for Flu the day before I got there. And so that one was just recently released, 1177, and it had Kirsty Short, Eric Carlson, and Rebecca Cox. So, and the one that I did from the meeting itself was 11. Well, one of them was 1177, and the more recent one was 1177, and then the one I did was 1169. So that was a really great experience. The pick that I have from 2024 is from TWiV 1117, and the title of the episode was Paul Dances with the RNA That Brought It. And it's about hepatitis B. And Rich had several different episodes where he talked about the crazy lifestyle of the HBV virus. And so you can go back and listen to that one, the full episode for that. The title of the paper was Deep Mutational Scanning of Hepatitis B Virus Reveals a Mechanism for Cis-Preferential Reverse Transcription. And at the time, it was paywalled, but now it's no longer paywalled. So Vincent asked us to give updates. That's one update about the paper. It's no longer paywalled. And the gist of the story, for me, the paper stood out because it really combined classical and modern molecular techniques, and it provided really exciting new data and findings that should be in the textbooks, as Vincent put it in the episode. And so just to give you the overview, the viral polymerase of HBV acts as a reverse transcriptase. And so sometimes in the episode, we called it the polymerase. Sometimes we called it the reverse transcriptase. I hope that wasn't confusing to people, but it's one and the same. It works in cis, meaning that it replicates the RNA that it was translated from. And how it does this has been something of a mystery, and it's pretty much solved by this paper. And so the first two authors of the paper are Yingpu Yu and Maximilian Cass, and the two corresponding authors, Charlie Rice and William Schneider. So the genome is complex. It has overlapping reading frames, and this polymerase is overlapped by every single other viral protein at one point or another in the polymerase open reading frame. So what was the deep mutational scanning that they did? Well, they took the core gene sequence, another viral protein sequence, and they put the nucleotide sequence in a DNA plasmid, and they put in a library of mutations that changed all the codons, put in all the codon variations that are possible for this core gene. And then they used T7 polymerase to transcribe it and put that RNA into liver cells. And then they waited 2 days to see how much DNA was made, and they sequenced the DNA. And so this was their deep mutational scanning, and then they did this analysis of what came out of it by doing the sequence analysis. And they also introduced it, or they also combined that data with AlphaFold data, which is something that came up several times in 2024. So AlphaFold is a protein analysis software that can determine the 3D structure, predict the 3D structure, I should say, based on amino acid sequence. So they combined those two things together to identify additional new things about the polymerase gene itself. But for me, the two major findings that they came up with this deep mutational scanning were two things that are near and dear to me, and that's things about how viruses affect translation. And so one thing is that they got data that pretty much clearly supports the hypothesis that had been out there that there's what's called leaky scanning to translate the viral polymerase. So leaky scanning, as we explained it in that episode, is basically that instead of the first AUG being the one that's used to start a protein, the first one at the 5' end of the messenger RNA, the ribosome, by some mechanism or another, and there are several, skips over that and maybe skips over the next AUG and the next AUG, which is the case for this HBV polymerase. And so this deep mutational scanning provided really nice data that supports that. And then the even more exciting thing is the data that start to solve this mystery is of how the polymerase does its cis-acting activities. And so what was found was that there are 2 prolines at the C terminus of the viral polymerase protein. So the ribosome is going along, translating the messenger RNA. It gets to the end where there are these 2 prolines, and it stalls or it pauses. And what that does is allow the polymerase protein, which is already able to sort of start to fold and so forth, somehow hook up with and get tethered to the RNA that it's being transcribed from. So that produces this cis opportunity where the polymerase protein is now associated with the RNA that it was transcribed from. And that allows the polymerase protein to be packaged with that RNA, and then that packaging leads to it being the primary thing that molecule, as opposed to a trans-acting RNA, this cis-acting one that's there and tethered or had been tethered, can get translated. So this solves that mystery. And the authors point out that there's something of a precedent for that in at least one other situation, but also could be the case for other cis-acting things in translation. So in other words, it could be something more broadly found in other biological systems, which for me is always a theme that I talk about when teaching, that something is discovered first in viruses, and people say, oh, well, that's just viruses. That can't happen in the rest of the biological world. And then, of course, it's found later to be true. So I think of that as being kind of exciting. And so then two final things. One is that, of course, then this allows all kinds of additional studies to be made about this kind of ribosomal stalling leading to cis activities and activities in translation, and could point to targets for antivirals. And then one thing that I noticed when I reread the paper yesterday, and I don't think we mentioned in the podcast, was that the authors suggest that this cis preference may be sort of a quality control that prevents the accumulation of defective genomes. In other words, if it gets all the way through and it gives you an active polymerase, then the RNA that was encoding it must be good. And so I thought that was pretty interesting and something that I think is worthy of being followed up. So I guess that was the update for me, was that I hadn't noticed that sort of quality control possibility.
We gave HPV a lot of attention last year. Usually it's rare, I think.
Yeah.
It's interesting. It just happens the way it is. Obviously, it's really important, and we're going to hear more about it as well. Okay, thank you. Brianne, you're next.
So I wanted to mention an arc that we talked about in a few different episodes that related to HPV, human papillomavirus, and specifically the human papillomavirus vaccine, and sort of data about how that vaccine is working. This vaccine was recommended first in 2006, and the HPV virus can lead to a number of types of cancer, in particular cervical cancers. And it seems as though in the time between 2006, when that vaccine was first recommended, and 2024, was the right amount of time for there to be some epidemiological studies to see the effect of this vaccine in the population. And so we had 3 different episodes where we talked about papers that were epidemiological studies looking at how HPV vaccine influenced cervical cancer. In addition to those 3 epidemiological studies, in episode 1159, which was released on October 20th, Vincent interviewed 2 scientists from the Karolinska Institute on eliminating cervical cancer and endometrial immunity, particularly about a plan to eliminate cervical cancer in Sweden. But we first talked about this in during 2024, the first we talked about this was in episode 1083, which was released on January 28th. And there we covered an epidemiological paper from the Journal of the National Cancer Institute that looked at the epidemiological data from Scotland, from the the Scottish Cervical Cancer Screening System, and Cancer Registry and Immunization, and saw that that cervical cancer, specifically invasive cervical cancer, was dramatically reduced, and in fact prevented by this HPV vaccine. And so those data are, of course, very exciting and very promising. Then in episode 1151, which was released on September 22nd, there was a Journal of the American Medical Association paper that was an epidemiological study looking at the different counties in Texas and the cervical cancer rates in those different counties versus the vaccine availability, and showed that in counties in North Texas where there was reduced vaccine availability, there were higher levels of cervical cancer. Again, kind of showing that this vaccine was having a real impact in the population. And then finally, on December 8th, in episode 1173, we talked about another paper from the Journal of the American Medical Association, this one looking at cervical cancer mortality rates in U.S. women during the years 1992 to 2021. And so this was sort of looking at the U.S. over 25 years to see if this vaccine had had an impact. And in fact, this paper indicated that there was a 12% per year decline in cervical cancer incidence but from 2012 to 2019. So that's overall a 65% reduction in cervical cancer. And and they looked even more closely at sort of this over different time periods based on when the vaccine would have been given and how long those women would have had post-vaccination and things like that. And these data were pretty impressive, looking at a rather large population of women. And so all of these things, I think, taken together really show us how useful this vaccine is in preventing cervical cancer, and point out the importance of vaccines and the importance of some of the work that scientists are doing to combat viruses that have now really shown up in the population level in multiple different settings.
Didn't realize we did so many HPV episodes.
Yeah. I think, if there isn't one already, there should be a book on the history of research on HPV, because it is an amazing example of infectious disease research, Vincent.
Maybe even some basic science.
Yeah, and what it can do. I was just looking up. It was Harold Serhausen, we've talked about this before, who first identified HPV as having a strong association with cervical cancers, and that goes back to 1983. But it's like many years earlier that the papilloma viruses were discovered. But it's gone from an association with the disease in 1983 all the way through a vaccine that can prevent cancer. And an amazing journey along the way. It's just involving all kinds of people standing on the shoulders of the giants before them. And it's just an amazing story of what we can do if we cooperate and put our minds to it, and put a little money in the pot too.
I think the show papillomaviruses were the first, right, in the 1930s.
Yeah, right. Absolutely. Yeah, that's correct. Yep.
I was just going to say, I was thinking that maybe we should try and get one of the really good science writers to put this on their list of things to do, and then maybe Rich could, help them. Or Rich,
Yeah.
you could write it and get one of them to help you.
I'm not going to write anything. I had writing is not one of my favorite things to do. I like writing emails. Okay, and that's about as far as it goes. It's you gotta really love it to really write.
Yeah.
It's really hard work. Actually, the first person that comes to mind, who's the dude who wrote Spillover?
Kwame.
Quammen.
Yeah, David Quammen.
Yeah. Let's twist his arm.
Mm-hmm.
I just think it's, as we might be talking about reminding people of the importance of vaccines sometime around now, all of these data being put together to really show the impact on this vaccine, and all of these things that, as Rich mentioned, have happened in my lifetime,
Yeah.
Is a great story.
Well, as I've said before, I was teaching this stuff all through this process. And, although not working on it, watching these developments quite closely to keep the teaching up to date. And the progress is just amazing stuff.
On the live stream this Wednesday night, I was talking about virus structure, and I was talking about self-assembling virus-like particles like HPV, right, for the vaccine, and HBV. And one of the listeners had worked on the HPV vaccine.
Oh, cool.
And he or she was saying how they had to tweak it so much. It took a lot of work to do this and that. And the listeners were like, had no idea. It's too bad nobody knows this to
Yeah.
realize what kind of work goes into these things and so forth, right? But it's true. People don't know what goes into making vaccines like that. It's unfortunate.
Vincent, you must have Kwamen's email address, right?
I do, yeah. I can send it to you. No problem.
Yeah, send it to me. And when this episode gets published, I'll bookmark this clip and
Okay.
and send it to him. Put a B in his bond.
One more thing I wanted to mention, that this conversation I had in the Karolinska about HPV, eliminating cervical cancer. So they have a goal in Sweden to eliminate cervical cancer by a certain time. It seems doable. But what was interesting, he said during the pandemic, they couldn't do pap smears anymore, right? So they would send swabs to people at home. They would do it at home, and they'd just do a PCR. And he said, it doesn't matter what the lesion is. If it's HPV negative, it's not going to be cancer. If it's HPV positive, then they would bring them back in for checkup. So now he said that's all they do in Sweden. No more pap smears. Can you imagine the gynecologists are probably pissed off that they lost all their business? But he says, all we do is PCR for HPV. HPV is all that matters, whether it's present or not.
I'm thinking more about the gynecologist patients and how much they probably enjoy the lack of pap smears.
Yes.
So basically, he said, if you have if you're HPV positive and you have a lesion, then they'll laser the lesion out, right? Get rid of it. But it's amazing, right?
It's
You don't have to
amazing.
take cells and have a pathologist look at them and score them and so forth. You just do a PCR. I love it. It's great. Okay, Rich, you're next.
So my next pick for the year is that we did a bunch of stuff on Mpox. Now is the disease, right?
That's right.
Monkeypox is the virus. I'll screw
That's
that up. I counted the episodes that I was on, and I wasn't on all episodes this year. I counted 5 with monkeypox. There may be more. 1095, 1119, 1143, 1145, and 1147. And I'll try and just very briefly summarize. If you'll recall, so monkeypox is a pox virus, inappropriately named because it is inappropriately named because it was first found in monkeys, but that's not its natural host. Its natural host is rodents. It is endemic in several areas in West and Central Africa. That's where it mostly is. It's reasonably closely related to smallpox, and it can cause a smallpox-like disease in people in that it causes a blistering and disseminated disease, but it's not nearly as contagious. It's transmitted by direct contact rather than by inhalation or aerosol, and it doesn't have nearly the fatality rate of smallpox. So it has a much lower incidence and a much lower fatality rate. So by and large, over the decades, it has not been a very prominent, shall we say, issue. Among other things, because the population was vaccinated against smallpox, which also immunizes you against monkeypox. But as the vaccination, the smallpox eradication campaign was over and smallpox vaccination no longer happened, there was a non-immune population that arose, and monkeypox infections arose along with that, mostly confined to Africa. Then, as people will recall, there was I don't know what you want to call it, a spill out in 2022, 2023, where some monkeypox clade 2. There's two clades, clade 1 and clade 2. Clade 1 is has the higher case fatality rate, up to 10%. Clade 2 is down around 1% or less, and it's clade 2 that spilled out into the global population, transmitted primarily by in situations with men who have sex with men, and that was taken care of, in my mind, mostly by education, understanding what the issue was and becoming aware of it and preventing the transmission. But in the last year, and maybe a little longer than a year, there has been you could call it an outbreak or an increase in monkeypox incidence in the DRC and Congo and Central and West Africa, involving clade 1 and a new variant of clade 1 called clade 1b. That is the clade that is usually associated with a higher case fatality rate, though I think as things are going to turn out here, it's not too bad. I don't know I was trying to look over what the overall case fatality rate is in this circumstance, and I can't really find any good numbers, but I think it's very significantly less than 10%. It may be down as low as 3%, though 3% is pretty high if there's a lot of cases. This is mostly in, the biggest problem is in children, and it's once again spread by direct contact. There are very close contact within families in a lot of these communities, with people providing care with each other, and this is still ongoing. We're not done yet. And so to emphasize that, I went to the source for this kind of thing, which is the World Health Organization, looking for a situation report, or SITREP, and I've provided a link here to a December SITREP on monkeypox virus, where you can see what the current situation is. And there is an ongoing outbreak in, as I said, Congo, DRC, West Africa, that is, still going on, and they're dealing with it. It's I think mostly the way to deal with it is various and sundry public health measures, but of course in those areas, because of conflicts and issues with public health infrastructure, that sort of appropriate public health attention is hard to come by. But it's not spreading. The global spread is pretty much done with for the time being. Also, I want to point out something that Kathy brought to my attention some time ago, but we never, I don't think, talked about it, which is an NIH report on a tecovirimat trial. Now, tecovirimat is an anti-pox viral drug, originally went under the name of ST246, also called TPOX, researched and brought to the market by a company called SIGA, and has been stockpiled in the U.S. It was developed as an anti-smallpox drug. And relevant and interesting is that this, the approval of this by the FDA was an interesting process because you can't do an appropriate clinical trial for a smallpox drug in humans because smallpox isn't circulating, and you can't infect people or whatever. So what the FDA developed was called the animal rule, or the 2-animal rule, where you had to prove effectiveness of the drug in 2 appropriate animal models. Those included monkeypox. Okay. I don't know that those were the ones that were ultimately most heavily relied on, but the research for tecovirimat involved a number of different related orthopoxviruses: vaccinia, smallpox, monkeypox, and others in a variety of different animal models. And it was remarkably effective in both cell culture and in various animal models. I was pretty close to this. As a matter of fact, I sat on the FDA panel as an ad hoc that reviewed the final thing and voted to approve it. And I had been, involved at least as an observer of this whole thing from the very earliest days of the research on this drug, and it never failed. It was a remarkable drug, but the situation with monkeypox in Africa provides the first situation where you can actually conduct a human trial. And so there was a trial conducted in children in Africa for monkeypox. And over a period of time, it was found to be safe. That's good news. But it wasn't effective in decreasing the lesions, decreasing the time to recovery. And so from a practical point of view, it was not effective. Now, and I can link this so people can look at the details. The report's pretty good. I did not look at the study itself. I had a discussion about this with one of my poxvirus friends, and his immediate reaction was that the circumstances of the clinical trial were such that the people who received this were probably well into their disease by the time they got it. And so that could compromise the effectiveness, as we know from our experience with other antivirals. It's really important if they're going to be effective to get them very early in the disease. And that would be hard to do in a situation like where this is done, because people are not going to show up with monkeypox in most of these situations until they're well into the disease and are showing very obvious signs, which is the blistering associated with it. Not only that, but I don't think that this study had any meaningful statistics about whether or not the drug had an impact on serious disease or fatalities. Okay, I'm not entirely sure about that, but that's an important criterion as well, to study the drug under circumstances where there might be a high mortality rate, and can you lower that mortality rate with the drug. So I'm shocked that this didn't exhibit more benefit than it should, than I expected it to. They have not stopped trials with this drug altogether. I think there are trials still ongoing, in particular in people who are immunocompromised, and et cetera. So it remains to be seen, but that's an interesting update, and I will keep an eye on this. I will keep looking at this and see if I can find the specifics about their conclusions for you.
One thing I want to point out that I've picked up from listening to Daniel's clinical updates is how much of a problem Mpox is for children in Africa, particularly in the Democratic Republic of Congo. It disproportionately affects children under 15 years of age, and part of it is due to likely comorbidities, poor healthcare access, malnutrition, and high prevalence of other infectious diseases. But of course, what it also points out is that, if you're still thinking about it mainly being transmitted through sexual contact or close contact like that, that's not likely to be the case for children, where it's contact with infected animals or people within their families in some other way. So it's something that I've become more aware of and sort of more concerned about. And I think I remember even hearing it being mentioned at the Options 12 meeting in Australia by one of the final speakers, one of whom was a WHO official. So it's something that I think is, as Daniel always says, no one is safe until everyone is safe. And that's something that concerns me about.
Here's the conclusion. It was in the first sentence of this. The antiviral drug tecovirimat did not reduce time to lesion resolution or have an effect on pain among adults with mild to moderate clade 2 Mpox, and a low risk of developing severe disease. Okay? So that's not the most stringent test that can be applied or the most critical situation. Nevertheless, it's odd to me. Well, maybe not. As I said, these people are probably in pretty advanced stages of the disease at the point at which they were enrolled, in which case it may be too late. So we will see. We will see.
All right, another big one for 2024 was avian H5N1 influenza virus. Actually, it's been a big deal for a number of years now. We did a couple of episodes on this. As you know, previously, the epidemiology and the ecology of this virus. So it emerged in people in 1997 in Hong Kong. It emerged in birds before that. And there were sporadic cases around the world as migrating birds carried the virus. And a couple of years ago, the ecology changed. The birds went all around the world and didn't respect seasons. So now they're carrying virus all the time. And as you know, in the U.S., it has now infected many dairy cow herds. And we talked with Richard Webby about that on TWiV 1113, influenza virus H5N1 in cow's milk with Richard Webby. So that'd be a good one to listen to. We also did one TWiV 1131 mutant influenza H5N1 virus. This page is all screwed up. Why is that? There's no video, there's no audio, there's no links. Oh, okay, I'll have to check that. Anyways, about the pathogenicity and transmission of a bovine isolate of H5N1 influenza virus. In TWiV 1173, holy cow, convergent evolution. And then the 1173, we did a paper, human isolate of bovine H5N1 is transmissible and lethal in animal models. So what's very interesting about this is that there have been many dairy workers infected with these bovine H5N1s, and for the most part, the infections are mild. It's in contrast to when you get an H5N1 from a bird, which is a different clade, it can be lethal. Yet in this paper, in ferrets and in mice, it was lethal and transmissible. So not sure what that means. So this is going to be something to really watch in 2025, right? Everyone is worried about it. Is it going to become a pandemic virus? Nobody knows. If someone says they know, they're wrong because we have no idea. What it needs to be a pandemic virus is to become human-to-human transmissible, right? Which it is not right now. And who knows if that's going to happen or not. Can't predict it.
Probably ought to do some infectious disease research.
We should. Yeah, we should. So, but what's good is that we're aware of it. It's not going to pop out of nowhere like SARS-CoV-2 or 2009 H1N1. We had no idea that was coming. We can make vaccines relatively quickly. We have antivirals that all work against H5N1. So I would say we're better prepared than we have been for previous other pandemics. So I'm thinking this is not going to be a pandemic, but that's a total guess, only based on the fact that it's been circulating for a long time and it hasn't. But it is in more animals now. So in the U.S., it's in many different kinds of animals. It's in wild birds, it's in poultry, cattle, wild mammals, cats get a lethal infection, farm animals. So the more animals it infects, the more potential for mutation and reassortment.
Yeah.
Who knows?
I have found this whole story pretty fascinating. I know that I know for a fact that we were talking about it actually in 2023 because there's a course I teach every other year, and it was the last time I taught that course, where the students still remind me that I was listing some of the mammals that had been infected. And my list included sea lions and land lions. I don't know why I went with land lions, but so I know sea lions and land lions were part of it. But I feel like, particularly with the cow story here, there have been so many things that it seems like we have learned about influenza and cows that we hadn't known before, and that raise really important questions about what might be going on with viruses in animals outside of humans. And it reminds me of one of the things I always enjoy as I learn about infectious disease is how many things in sort of the breadth of biology I end up having to learn and be able to talk a little bit about. In December, ASV had a webinar for members on H5N1. And the two speakers were really kind of involved in veterinary and the sort of farming industry. One of them talked a lot about her work in sort of thinking about cows. And I learned more about what was going on in sort of the dairy industry in that webinar than I had ever learned before. And so I think that this has just been really fascinating to me in terms of what exactly what kind of things I never would have thought about learning about when I was an undergraduate, or that I never would have thought that were going to be really important to my life as in biology.
Not clear that it's ever leaving cows, right? They don't get very sick. They don't die. It just spreads among different herds. And
yeah, but apparently a lot of that is related to the movement of cattle among around the United States, and where cows are bred and how they're moved. I was learning all sorts of things that I had never thought about.
The movement?
The movement.
The movement, yeah. All right, Brianne, you're next.
The next thing I wanted to mention was something that we only talked about sort of briefly. Was really the episode that I'm mentioning here talked about this as one of our news items, but I think it's an important story to remind people about. Since COVID has started, I have been really intrigued by some of the stories that have been out there about how some of our public health interventions have influenced viral transmission as a whole. I know that at one point this year we talked about changes in respiratory viruses in New Zealand because of their movement restrictions and things like that. And one of the stories that has been related to all of this has had to do with a type of influenza virus, specifically influenza B Yamagata. So there are multiple types of influenza. Typically we think about influenza A, but influenza B can also cause a number of issues. And typically when we get an influenza vaccine, that influenza vaccine is a quadrivalent vaccine that includes two prominent influenza A strains and two prominent influenza B strains. I've gotten the quadrivalent vaccine for I don't know how many years. in a row. And after some of the non-pharmaceutical interventions, after some of the masking, lockdowns, etc., you can't really figure out exactly what to tie it to. When people were trying to do some detections of the influenza B Yamagata strain, they found that it seemed to disappear during during this time when we were locking down and stopping respiratory virus transmission. And so inadvertently, we may have made influenza B Yamagata extinct. And that led to this virus actually being removed from the influenza vaccine, which we talked about in TWiV 1161. And so this vaccine that has been a quadrivalent influenza vaccine for quite a while is now back to being a trivalent. Because of all of these interventions. So when Vincent was talking about the report earlier and how some people were, upset about masking and upset about some of the interventions and how terrible they were, I think it's important that we also look at some of the data like this that show us some of the positive consequences that have happened. Yep. We are not potentially at risk of influenza B Yamagata anymore, to the point where it was able to be taken out of the vaccine. And I think that's a big success that we should talk about more.
Yeah. We talked a lot about polio last year. And I don't know, it's because I'm very interested in poliovirus, having worked on it my whole career, I think. But just to review, WHO declared they would eradicate polio back in 1988. There are no more cases of wild type 2 and 3 poliovirus, as far as we can tell. So it's been a success in that sense. But the type 2 vaccine virus, so the WHO is using oral polio vaccine, of which there are 3 serotypes. The type 2 component causes poliomyelitis, it transmits, and you have outbreaks caused by type 2, even though type 2 was eradicated. The vaccine type 2 continued to circulate and cause polio. So in 2016, WHO said, we're going to take the type 2 out of the vaccine. So they took it out of the vaccine. And for a while, there was not a lot of environmental type 2. But all of a sudden, it started up again in a couple of countries in Africa. So they had to go back in again with monovalent OPV2. And that just kept seeding more and more outbreaks. In fact, there have been thousands of type 2 OPV made outbreaks, more than there ever were before. So WHO and the Gates and CDC decided to modify OPV2 to make it impossible to revert. It's actually in the title of the paper. And in January of 2024, the WHO pre-qualified NOPV2 after a lot of clinical trials. So in other words, saying that it could be used. Despite, in September, I think, there was a report which said after administration of 750 million doses of NOPV2, it caused 49 outbreaks and it was present in 27 environmental samples. And in fact, NOPV2 derivatives were found in Zimbabwe, where the virus was never used. And we talked about that on TWiV 1091. Now, type 1 is only found in Afghanistan and Pakistan, and problems with vaccination has led to an expansion of type 1, wild poliovirus type 1, out of the normal endemic zones. We covered that on 2 TWiV episodes, 1125 and 1105. In April, OPV2, vaccine-derived OPV2, was found in Budapest sewage. Budapest was polio-free previously. Angola, it was previously polio-free. In June, was found in wastewater in Gaza, traced to an isolate from Egypt. And 10 weeks later, an infected child was found in Gaza. We talked about that on TWiV 1151 and 1145. Subsequently, type 2 found in Indonesia and India, where it had been absent for years, TWiV 1147. And in June, there was a report authored by Roland Sutter and others and summarized in Science saying this 2016 switch was an unqualified vaccine policy failure, which led thousands of kids to be paralyzed. There have now been over 4,000 cases of paralysis caused by OPV2. And NOPV2 is no better. It's marginally better. It doesn't solve the problem. NOPV2 has been used in Gaza. It's been found in Barcelona, Warsaw. In circulating vaccine-derived polio 3 has also been found in French Guiana off the coast of Brazil. It's in October. It was found at 11 sites in Germany, in the UK, in Finland. This is all wastewater surveillance now. These are no paralytic cases. You never find this before. That's because these type 2 viruses, OPV type 2 viruses, are circulating everywhere. If you go to the polioeradication.org site, first of all, we talked about on TWiV 1161 how they took away the map showing you the current polio cases. And now they just tell you how many countries have polio, both wild type and vaccine derived. They say it's in 46, vaccine derived type 2 is in 46 countries. That's a lie. It's in over 65 countries. It's just a lie. They're trying to hide the information from us. We talked about polio in Europe on TWiV 1175. Just today, poliovirus type 2 was found in Algeria. 52 environmental sites were positive. And not too long ago, also in Australia. They don't use it, but someone traveled into Australia who had received OPV and OPV2, and they shed it, and it's ending up in the environment. So this virus gets around, and the more it's used, the more it gets around. So we need to have a reassessment of the eradication strategy. Can't use OPV anymore. You know, OPV is delicensed in the U.S. because it paralyzes people. So it shouldn't be used globally. We also had Tapani on TWiV when I visited Finland. He had worked in the National Health Institute for many years doing environmental surveillance. He talked a lot about the caveats of environmental surveillance. You know, all these countries are doing wastewater sampling for poliovirus, except the U.S. The CDC will not permit it. And I think they should because, you know, here's the problem. RFK Jr. says we don't need the polio vaccine. And people in the U.S. may go, oh, yeah, there's no polio in the U.S. What do we need it for? Well, if you saw that throughout the U.S. environmental samples were polio positive, maybe you'd think differently about that. Yet the CDC does not permit it. I think we need to know, you know, we can see how much SARS CoV-2, norovirus, influenza, RSV, and wastewater. Why not polio? And this year, June 2025, you can no longer do poliovirus research in the U.S. You have to get rid of all your samples, which is a big problem because we do need a better vaccine. We do need more research. The only way you can work on polio is if you are declared a polio essential facility, but you can't get any money because NIH will not support any poliovirus research. So the whole situation is, may I say, verkakte, okay? It's really a mess. And I just want to end with a quote from Albert Sabin. Albert Sabin said his vaccine strains, the OPV strains, should be used in massive campaigns. And the WHO is doing little mop-ups here. There's an outbreak here. They go, Gaza, for example. There's one case. They go in and they immunize. And they go somewhere else. And Sabin said, that's not the way the vaccine is designed to work. He was frustrated by failure of WHO to adopt massive synchronous vaccination campaigns. He wrote, in my judgment, global eradication of poliomyelitis will not be achieved by the year 2000. He said this in 91, the goal set by WHO, and not for a long time by the procedures now being followed. And it just seems to me that the people in charge of this are not recognizing the issues and dealing with it. They're still thinking, yeah, we're going to use NOPV2. By the way, NOPV1 and NOPV3 are being clinical trialed at this very moment, which adds to the disaster. You should be switching to IPV everywhere. And we're going to talk about this more in 2025. Okay.
Holy cow, Vincent.
What?
That's pretty bleak.
Yeah, it is. And, you know, here's the thing. So let's say some judge somewhere gets this request to stop the use of polio vaccine, some idiot judge who doesn't know any science. The judge may say, okay, until we decide, let's put a hold on the use of polio vaccine because you seem to think it's an issue. You know what's going to happen? In a couple of months, we're going to have outbreaks of polio in the U.S.
People are going to wind up
crazy.
paralyzed. Yep.
It's crazy. I mean, to even consider this guy for HHS head is crazy if he says stuff like that. Yeah. Okay, Brianne, you're next.
So I also noticed that we had another arc that is near and dear to my heart. And this is an arc that we've been talking about again for a few years, but we hit it pretty hard in 2024. And this is sort of this general idea that protective immunity, whether that is immunity that's coming from a vaccine, whether that's immunity that's coming from infection, whatever, immunity that is protective from disease upon secondary infection isn't just about neutralizing antibodies. And so often we think about neutralizing antibodies as being a correlate of protection. When we are doing vaccine trials, we tend to measure neutralizing antibodies sort of exclusively. And we talked about a number of papers this year that showed the importance of some other forms of adaptive immune responses or even non-adaptive immune responses in providing protective immunity. So this, and what was really interesting in looking at this is that I think in some of the past years when we've talked about this, we've really focused on SARS-CoV-2 papers and SARS-CoV-2 vaccine papers to think about potential protection by things like T cells. Some of people may remember all the way back to 2020 when we were kind of asking, what about the T cells? But when we look at the papers that we talked about this year on this, we weren't just thinking about SARS-CoV-2. We were thinking about a lot of different viruses and seeing this theme of protective immunity by things other than neutralizing antibody responses showing up over and over again. In episode 1089, we talked about a paper that looked at prevention of respiratory virus transmission. And so I think the fact that it was looking at multiple respiratory viruses and that it was looking at transmission, both is really cool, specifically by resident memory T cells, as opposed in the respiratory tract, again, as opposed to neutralizing antibodies. Resident memory T cells are particularly challenging to measure in a lot of settings. But I think it's important that we see that they can be involved in prevention. Then in episode 1105, we looked at a study that indicated antibody-independent protection. So again, presumably T-cell protection could potentially also be things like NK cells against heterologous SARS-CoV-2 challenge. In episode 1115, we talked about how baseline innate and T-cell populations were correlates of protection against influenza. And this was independent of serology. So again, we're seeing things other than neutralizing antibodies that seem to be really important in protection. In 1135, we talked about protective but non-neutralizing antibodies from survivors of Crimean Congo hemorrhagic fever virus. So again, we're looking at a lot of different kinds of viruses. We sometimes see antibodies, but those antibodies are doing some function other than neutralization. And sometimes we're seeing T cells, sometimes we're seeing innate cells. And the innate cell theme came up again in 1165, where we talked about trained immunity. So not even a classic adaptive immunity, where we saw a paper that talked about antiviral trained innate immunity in alveolar macrophages after SARS-CoV-2 infection reduces secondary influenza A virus disease. And there are a bunch of other papers I could have pointed to that we talked about this year as well. And so I think that this shows us kind of as a theme the importance of the immune system outside of neutralizing antibodies, but also reminds us that when we're thinking about vaccine development, we should think about platforms that can induce some of these other responses. And when we're evaluating vaccines or protection from from infection or what have you, we need to be able to measure some of these other responses. That might mean that we need some different techniques that to become more widely available sort of clinically outside of a fancy immunology lab. And I hope that, in the future in 2025, we start seeing more about that and also more about ways we can really dissect some of these responses.
I think it's a really interesting arc. I like whenever I see a good paper that says there's stuff other than antibodies, I really like to talk about it. But when we go to make a vaccine, we just do the easy way. We look for antibodies. But
yeah, and so, and that may be a little bit of a failing on immunologist part for coming up with easy ways to measure some of these other things.
yeah. Well, you need all of it, right? In the end, you don't just need one or another. You need the antibodies, you need T cells, you
Of
need
course.
antibody independent, FC mediated. You need it all.
Mhm.
That's why it evolved all, because you need it all. right?
Exactly.
And so if you just focus on antibodies, you end up having variants that get around them, right?
Right.
Very cool. All right, one last fun one. TWiV 1083. If you close the toilet, it doesn't reduce aerosols. So this was a study in the American Journal of Infection Control. Impacts of lid closure during toilet flushing and out-of-toilet bowl cleaning on viral contamination of surfaces in United States restrooms. There you go. It could be different. So they basically took a toilet, they put bacteriophage in, which you could measure easily. And then they flushed the toilet with the lid open or closed. And they swab the room, and the room gets contaminated whether the lid is open or closed.
Ew.
Yeah. I mean, I still close the lid, but when I do, I think I'm screwed. It's still coming out. I like that a lot. There you go. That's 2024 in virology. That's from our viewpoint here at TWiV. Right?
Interesting to see that the different takes that each of us has. I don't think we were fighting over any articles or arcs.
Yeah.
Everybody's got a different perspective.
Oh, there's a lot, right? It's 52 episodes. And we don't even include Daniel. And maybe in the future we should have him come for this and do his favorites.
Yeah, I made myself a little Word document and was typing notes as I went back through the episodes over the past year. And it was amazing how many different ideas I had of arcs and things that we talked about. There's a lot.
But I like the Hep B and the Hep HPV and the non-antibody arcs. I didn't realize those at all. That's very cool. All right, let's do some picks of the week to begin this new year. Yeah. Brianne, what do you have for us?
So people also may know that I find bats and bat biology rather interesting. And this is an article that was in the New York Times. I read about this paper in a few other places. But the general paper is about the idea of some scientists getting vampire bats, which are, in fact, the only mammals that survive on blood of other mammals, and putting them on a treadmill to look at their metabolism. So bat metabolism is particularly interesting. It may involve their immune responses. Vampire bats are especially unique because of this eating blood, which, of course, has a very different profile of nutrients than things like insects or fruits, which other bats eat. And so if you go to this New York Times article, when you click on it and you go to the top, there's a video of a bat on a treadmill. And there are pictures of bats on treadmills and videos of bats on treadmills throughout. And even if you didn't read anything about it, I really like the bats on the treadmills in the videos. But they actually showed in the paper that this is talking about that these bats, when they are under sort of metabolic stress, when they're running on their treadmill, they do a different type of metabolism than other organisms in how they break down amino acids for energy instead of carbohydrates or fats. And so that is particularly interesting. The New York Times article is actually called "You May Not Be Able to Outrun a Vampire Bat." And again, right at the top, you just see this bat on a treadmill. And so when I saw it, I couldn't not pick it. I think it's great.
It's cool. Very cool.
He's really chugging on one of these treadmills.
He is. He really is.
And what's this last picture? Are they showing us that they're returning this bat to his natural habitat or something like that? It's a cute little thing.
Yes. Yeah.
There you go.
Bat's really cute. There's one where they're feeding the bat with a syringe some blood.
Kathy, what do you have for us?
I picked a book that I finally finished listening to. It's called Says Who, A Kinder, Funner Usage Guide for Everyone Who Cares About Words. It's by Ann Curzan, who's a faculty member here at University of Michigan. And I think I've picked her short little 5-minute podcasts in the past. But this book is really great. It's available as a hardcover book, Kindle book, and audiobook. And the audiobook is read by Ann. And after I listened to the audiobook, I got the Kindle version because I want to be able to search it. And the gist of it is that you need to fight or be aware of your inner grammando and cultivate your inner wordy. And so we were all brought up with different grammar rules, and we like to bring them out and show that we know them and use them in various cases. But really, a lot of those rules she goes through the history of some of them, and some of them really don't hold up. And that what would be better is if you could cultivate your inner wordy and be curious about why is this happening, and, is this really the case anymore that we need to do this? And it's very entertaining, and she's got, it's a fantastic chapter list. There's 33 chapters plus a really engaging introduction and epilogue. She's got 5 chapters alone on punctuation, a couple chapter names just for your interest: data and other disputed plurals, verbing, for who, parentheses, M, the bell tolls. Another chapter is called Passives Were Corrected. And so I just find it really, really entertaining. And for anybody who thinks that they know how to edit and write, it's worth listening to this. She happily points out her own inner grammando things, places where she's just not able to give up the rules that she was brought up with or thinks about. But it's all just really well done. And as I said, I listened to it, but I'm happy to have the Kindle version so I can search it to find specific things that I remember hearing about. And I highly recommend it.
I'm thinking of Alan. He would like this.
I would love to read this.
Yes.
What does she feel about data? Does she think it's plural or whatever?
She's coming down with the vast majority of the media, which is that data can be however we don't like it. Singular, yeah.
Okay.
But also she recognizes, for instance, that the passive voice in science papers, particularly in materials and methods, the samples were treated and then incubated and then they were da-da-da-da. And she says, if you were to say, if you were to add in we, then you have this question of, well, who is we?
Yeah,
is that inclusive enough? And so forth. And so she recognizes all the different kinds of academic pressures that come into play for these kinds of things.
Yeah.
I like this quote about the book on the Amazon site. Ann Curzan has accomplished the feat of addressing every possible language peeve anyone ever has.
Yep, that's what it is.
Yeah.
It's cool. Right. Rich, what do you have?
So this is a kind of sort of repick. Listeners will understand that one of my favorite shows is the PBS NewsHour, and they have a series that they run called Brief But Spectacular, where they pick out individuals who, have an interesting perspective or interesting accomplishments on this or that stuff you don't ordinarily hear about. And they have them, actually the pieces are structured interestingly because it's entirely narrative from whoever is featured, with a stream of video in the background that shows them at work doing whatever it is they're talking about. And there was one on just the other night featuring Mark Rober, who we've seen before. And one of the reasons I picked this out was that until I saw this and sort of looked into it a little bit, I didn't realize that it was the same guy who had done all of these things that we've talked about before. So if you go back, I think one of our first encounters with him was, I think this was a pick of the week. This is the guy who built an obstacle course for a squirrel in his backyard because his squirrel was ripping off his bird feeder all the time.
Yeah.
And so he wondered, what can these squirrels put up with? And he built an obstacle course for the squirrel. And he noticed during a course of time that the squirrel was getting fatter, right? And it turned out the squirrel was not a he, it was a she, and she was pregnant.
Yeah.
And it was very entertaining.
That's funny.
He, there was another one that skips my, oh yeah. He's the guy who I think we've talked about before, who went on a crusade to ambush porch pirates and built packages and put them out that
With the glitter bombs.
yeah, that had glitter bombs in them or fart spray. Okay. So this guy runs now a YouTube channel that has over 60 million followers. Okay. He is a fairly young guy. He's in his mid-40s. He is a mechanical engineer who worked for NASA for like 9 or 10 years or something like that, where he worked mostly on the Curiosity rover. He worked then with Apple, and he says he has an NDA that's inches thick, so he can't talk about what he did. But he did show a patent about self-driving cars. He said that's public. They can't sue me for that. Then, they interviewed him about all the stuff that he'd done. So as I looked into this, I came up with a couple of more things that I've linked here. First of all is the wiki page that describes him. And the second that I would highly recommend to people, he's got a whole bunch of YouTubes that are really terrific. But this one that I picked, I found really entertaining. It's worth the 22 some odd minutes. It's called Testing the World's Smartest Crow. And just to give you a preview, the development of these is amazing. He starts off after some introduction by saying that he gets DoorDash embarrassingly frequently delivering chicken nuggets to his doorstep. And he's got videos from his porch camera that shows that these crows reproducibly rip off his deliveries of chicken nuggets, okay? And, he recognizes from this that the crows are not stupid. They know what's going on. And crows actually have a reputation for being pretty smart. So he decided he was going to test just how smart they are. And he went out and got himself a rescue crow and built an enclosure for it with lots of different activities that the crow could do. Kept him in there for a while. And then built a challenge for the crow, which he calls a crow escape room, which is appropriately named. It has a table with a bunch of chicken nuggets on it, covered with a cage. And the cage is on a pulley system. And if you trigger the cage properly, it will pull up and reveal the chicken nuggets. And he's got 9 different challenges, puzzles that the crow has to solve in sequence. And a lot of them are related one to another. So it's got to be in sequence that the crow has to figure out in order to open this cage. And he even tested on a couple of kids to sort of make sure that it's manageable. And it's not only hilarious, but astonishing. This crow is amazing. So crows are really smart creatures.
I want to know how he knows it's the world's smartest crow.
Well, that could be an exaggeration. Who knows?
Didn't know you could get a rescue crow. I guess you can get a rescue anything.
I suppose.
My gosh, that's
so
amazing.
That's a worthy video. And
Wow,
this guy
that
is
sounds
amazing.
really fun.
In his PBS NewsHour thing, he gets all weepy when he's talking about his teachers from the past. And he says, when I'm done with this, my guess is he's making a bundle off the YouTube stuff. Good for him, because they're very educational and they're really cool. I can't believe he has the energy to do this. It's amazing. He says, when I'm done with all this, I'm just going to be a volunteer K through 12 physics teacher.
Wow.
Good for him.
Yeah.
My pick is a YouTube video by Ben Loud. He has a channel. And this one is called How Glenn Gould Broke Classical Music. So I just stumbled across it last week, but I remember many years ago, hearing someone say, Glenn Gould doesn't like classical music. He plays it so slowly. So this gets to the bottom. I mean, Glenn Gould was a brilliant pianist. If you listen, it's just incredible. His talent was amazing. You go to his wiki page, you can read how his mother, when she was pregnant with him, she played music. As soon as he was born, she would play music for him. And he was a child prodigy. At 12, he was a concert pianist. It was amazing. But he was very quirky, right? He had to sit in this chair, a regular chair that his father had made. It was not a bench. It's a chair with arms. He was often bent way over on the keyboard. He used to sing while he was playing, and you could never get that out of the recordings, and people would get pissed off at it, Anyway, in April of 1962, there's an orchestral concert at Carnegie Hall. Leonard Bernstein is the conductor. So he gets up there, and he says to the audience, "Don't worry, Mr. Gould will be here." He's in the back, because he had a reputation of bagging out at the last minute. He said, "But I just want to say," they were going to play Brahms Piano Concerto No. 1. He said, "This will be the most different version that you've ever heard." And people was like, he threw Gould under the chair, basically. But he had arranged this with Gould. He said, "I'm going to say this because your version is totally different." So what Gould did, the very beginning of this concerto, as well as throughout it, it's meant to showcase the virtuosity of the pianist with a lot of very rapid notes, right? And Gould said, there's no reason to show off. What you need to do as a pianist is to get the feeling out of the music. And I don't feel I need to play it fast. So he slowed it way down. And some conductors hated it and other people loved it. And this video goes through this whole story. The guy who made the video obviously loves him, because he said, and there are interviews with Gould where he says, basically, I'm trying to get the essence. I don't care what the conductor wanted. I don't care what the composer wanted, right? I want to play it so that I can feel the music. And I think that's absolutely great. I love it, right? So who cares if he plays it slowly, because they contrast him with, who's the famous Russian pianist? Vladimir something or other. Not Nabokov. Anyway, he used to play it like crazy, gangbusters, fast as heck. And he says, it's just showing off. You can't even hear the music. You can't even hear the notes. So I love it. I think it's just great. You're going to like this. But unfortunately, he died at 50 years old. All of a sudden, he had a stroke and he died.
Wow.
So he stopped playing concerts. He said, screw this. People don't appreciate what I'm doing. And he just recorded music. He went into the studio and recorded music. But he was so good. I mean, I don't really know much about piano, but you can just hear how beautiful he is, how beautiful his technique is. You hear every bloody note. It's amazing. It's really amazing. But this explains this comment I heard years ago. He doesn't like classical music. He plays it. How can you not like it if you're a concert pianist, right? That's ridiculous to say that. All right. I think that's it. Yeah, that's it for this one. No listener picks. Show notes for TWiV 1183 microbe.tv/TWiV. You can send us your questions, comments, picks to TWiV@microbe.tv. And if you enjoy these programs, we'd love to have your support to continue them. You can go to microbe.tv/contribute for the different ways that you can help us out. Kathy Spindler is Professor Emerita at the University of Michigan in Ann Arbor. Thank you, Kathy.
Thanks. This is a lot of fun.
Rich Condit is an Emeritus Professor, University of Florida, Gainesville. He is currently in Austin, Texas. Thank you, Rich.
Sure enough. Always a good time.
Brianne Barker is at Drew University, BioProf Barker on Blue Sky. Thanks, Brianne.
Thanks. I learned a lot.
I'm Vincent Racaniello. You can find me at microbe.tv. I'd like to thank the American Society for Virology and the American Society for Microbiology for their support of TWiV, Jolene for the timestamps, and Ronald Jenkins for the music. You've been listening to This Week in Virology. Thanks for joining us. We'll be back next week. Another TWiV is viral.